Good evening, everyone. I hope I am audible. I welcome you all to GRE Preparation Made Easy Quantitative Reasoning class by Mrs. Annapurna Murugan. Here are a few instructions for the participants. Make sure you have a stable internet connection and noise-free environment. We recommend to use your earphones for best experience. Also, respect your instructor, your classmates, and yourself. Do not write anything inappropriate on the chat box. Also, how to answer the polls. You have to click on the more button and then you'll see activities where you will find polls. We have three packages, that is bronze, silver, and gold. If you upgrade to silver and gold, you'll get extra benefits like evaluated mock tests, expert university recommendation, and dedicated counselor for entire application. We also have free profile evaluation with our experts, comprehensive evaluation, university shortlisting, course recommendations, recommendation reports, and doubt clearance. Also, live IEL classes are conducted Monday to Friday, 7:30 to 8:30 p.m. It is a 4-week course, and Duolingo classes Monday to Friday, 6:30 to 7:30 p.m. It is a 2-week course. You may register for free. Also, we have this Ubergrad webinar regarding the US student visa interview. It is being conducted by Mr. Jaideep, who is also the co-founder of Ubergrad. The webinar includes a detailed process, visa detailed process, tips to crack the interview, interview question types, and visa guide. It is this Saturday, that is 2nd December, from 7 p.m. to 8 p.m. You may register for free. Also, here are a few achievements. This is the Ubergrad website. You can select the country, course, and specialization. When you go on Explore, we have countries, universities, courses, and exams. You can get all the information from here. When you go on Solution, we have free profile evaluation, talk to the counselor, country recommendations, test preparations store, and additional services are provided as well as weekly blogs are uploaded. You may go through them. To contact us, you can call us, WhatsApp us, or mail us. When you go on My Test Preparation and click on GRE View Course, you find the handouts and the recordings. In case you've missed any sessions, you can get the handouts and recordings from here. Also, I'll be sharing the links and links for the Telegram channel, handouts and recording links, as well as webinar. You can go through them. And for any other doubt, you may ask at the end of the session. Thank you and have a great session.
Hi guys, good evening. I hope you people are doing good. Yes. Okay, today we are going to start off with our polygons. Okay, so let's work on with polygons. What are polygons? Closed figures, isn't it? Closed figure then is like a triangle can be considered as a polygon. Yes, we can consider a triangle as a closed figure because it's a closed figure, hence it is also a polygon. But however, so we dominantly get under polygons like more than figures having more than four sides, like from quadrilateral, pentagon, hexagon, heptagon, nonagon, octagon, decagon. So like this will be taking our polygons as well. So let me share the screen, and not just the sites and their respective names, but we have many more things that we need to know about a polygon here. Okay, just give me 1 second. Okay, so polygons, yes, so these are some of the things that we have. Okay, so polygons, any closed figure with more than two sides, we can consider them as polygons. Okay, quadrilateral, triangle, pentagon, hexagon, heptagon, octagon, nonagon, and decagon. They're all your polygons. Okay, so now like we have certain formulas, certain things that you need to know when you're talking about a polygon. We all know that triangle, we have triangle, what three sides it is. Okay, what is the angle sum theory of the triangle? Angle sum theory of the triangle. What is angle sum theory of the triangle? So it is, that means how many angles we have? We have three angles. So the sum of the three angles should be equal to what? 180 degree. Okay, about quadrilaterals also, take an example of one of the quadrilateral, that is rectangle. What is the angle sum theory of quadrilateral? So we know that sum of the angles, okay, the sum of the internal angles, what we can say, sum of the internal angles of the quadrilateral must go up to 360 degree. That means what? So you guys are seeing here, as the number of sides increases, the internal angles also increases, isn't it? The sum of the internal angles also increases. But then, so how do you guys find out if they give a polygon of many sides? So how can you find the internal side, the sum of the internal sides here? So how can you find? Here we are talking about the convex polygons. Okay, what we are talking about? Convex regular polygons we are talking about. Convex means what? Outer reflecting sides. Okay, so that means you will be having the outer edges, like see, this is also convex. So if I take like this, these are all convex. You can see that the closed surface is there. So outer reflecting surface we can say. Okay, so now what happens? So as the number of sides increases, the internal angles also increases. So how do you find out the total internal angle of any polygon? So what we can do is, we have a formula here. What is that? So to find the sum of the all the internal angles of the given polygon, so n minus 2 into, what is that, 180 degree, what we can say, it is given by n minus 2 into 180 degree, where n is what? Number of sides of the given polygon. Okay, so now if I have, so 9 nonagon, okay, so nine-sided figure. Nonagon is what? Nine-sided polygon I have. So if I want to find, so the sum of the internal angles, that means what? We can take 9 minus 2 into 180 degree. That is what? 7 into 180 degree is our this one. Okay. So what is it? 7 into 180 degrees. So how much, guys? Tell me. So I don't get the answers only. It is a simple multiplication. Then 1260 degree we have. Okay. So now let me take the simple check. Okay. So whether our formula goes correct. So triangle has how many sides? Three sides. So let me see whether the total internal angle we are going to get here, this one or not. 3 minus 2 is what? 1 into 180 degree. Yes, we have the angle sum theory, or the sum of the internal angles of a triangle is what? 180 degree only. You check it for quadrilateral also. We know quadrilateral, it is 360 degree. So therefore you people try to, what is that? Check it out. So if you see here, like what is that? 4 minus 2 into 180 degree, which is nothing but 2 times 180 degree, which is nothing but 360 degree we have. So you people can use this formula. So n minus 2 into 180 degree, or so you people also can use 2n minus 4 times 90 degree. This is also one of the formula you use. You may come across this formula or this formula. Okay, don't get confused. Oh, ma'am said this formula and but we have this. This is nothing but here what they have removed. They have removed 2 common, and 2 into 90 is 180 degree. So therefore, after removal of the common, it becomes n minus 2. Okay, so these are the two formulas that you people going to get in your this one to find the sum of the this one. Okay, let me erase all of this thing. Then let me talk about the internal angles. What will be the internal angles of this? Each internal, because we are talking about the concave, sorry, convex, so polygon, we usually consider this convex polygon as regular convex polygon. So here I'm talking about a regular convex polygon. So in the regular convex polygon, what happens, you see that all the internal angles will be same. Okay, so what is that? All the internal, so each of the internal, so angles will be same here. So here what happens, how to find each of the internal angle? So what we can do here, we know that this is the total angle. So if you divide by that many sides, you can say that, so that will be the internal. For example, let me take, okay, this is, let me take it as pent, 1, 2, 3, 4, 5. Okay, this is a pentagon we have. Okay, so this pentagon, how many internal angles? 1 angle, 2 angle, 3 angle, 4 angle, 5 angle. So these are internal angles, guys. So these are internal angles. So now what happens? Let us see first of all. So what is the total interior angle? 5 minus 2 into 180 degree. So that is what 3 into 180 degree we have. But here what we have, so if you want to find each of the internal, so 3 into 180 divided by 5. Okay, so how many times it goes? So 5 3s are 15, 35, 6 are 30. So therefore, so 18, 3 3s are 9, 108 degree. Each of this angle will be what? Obtuse angle, which is nothing but 180 degrees. So remember this formula. What is that? N minus 2 into 180 degree by n, where n is what? Number of sides. What is this n? So n is nothing but number of sides. This formula again, we had this one, right? 2n minus 4 into 90 degree. The same form in for finding the interior angle. So we can take 2n minus 4 into 90 degree divided by what? So n. Remember? This is the thing we have. Now, so I guess these two concepts clear. Let me, this one, what is that? So take up one more concept about the exterior angle. Let me take the eraser. Okay. So now you people know about, I don't know whether you guys know about the exterior angle or anything. Every polygon has an exterior angle. Okay. So remember one thing. So we see that every, this one, what is that? Polygon as exterior angle. Take, let me start with the triangle only. When you studied about a triangle, you would have come across this thing. What is exterior angle? The angle which is outside. This angle, that means 3 exterior angles. So each of this exterior angle is equals to the sum of the internal to opposite interior angles in case of triangles. Remember this. I gave you one more point. The exterior angle of a triangle will be equal to sum of the opposite interior angle. If this is y, if it's this is x and z, so y will be equal to what? x plus z. Why? Because you know that this plus this should be equal to 180 degree, and we know that this plus this both is 180 degree. So therefore what y is equals to x plus z here. So in that way, if we see, if I have this as y, a and b, you will be seeing that the sum of the exterior angles of this one, what is that triangle, should be equal to 360 degree. Okay, so here we saw that sum of the exterior angles of a triangle is 360 degree. What about other figures? See, here also what? 90 degree. These are exterior angles. Okay. So what are these? These are exterior angles. These also, the sum of the exterior angle is again equal to what? 360 degree. In the same way, even for what is that? So it could be any polygon. Okay. What you see? The sum of the exterior angles. Okay. So what is that we see? The sum of the exterior angles will be equal to what? 360 degree. No matter whether it is 10-sided polygon, whether it is 20-sided regular polygon, you see that the sum of the exterior angles, okay, the sum of the exterior angles, that means the angles which are outside the polygon will be equal to what? 360 degree. Remember this thing. Okay, this is one of the thing you people need to remember. Now, guys, one more thing you people need to know. What is that? Means diagonal. See, what is this diagonal? Can you find any diagonal in a triangle? We don't have any diagonal in a triangle. Remember, okay, we don't have any triangle in a diagonal in a triangle. Why? What is this diagonal? The diagonals are nothing but the line joining the opposite vertices. See, if I take a quadrilateral or any four-sided figure, you can see that we have this is one diagonal and this is one diagonal, isn't it? So what is this? This is one diagonal and this is one diagonal we have. So in a four-sided figure, that means what? We have this one. What is that? When the opposite, diagonally opposite, so vertices are joined, the diagonals are formed. Okay. So TK for quadrilateral, we have how many diagonals? Two diagonals we have. Okay. So for quadrilateral, how many diagonals we have? Two diagonals we have. What about the other polygons? How do you find out? So the diagonals for other, like if they give pentagon, if they give hexagon, how do you find it? Isn't it? So we can find by using the formula n into n minus 3 by 2. Okay, so that means if it is a pentagon, how many diagonals? It will be n is 5, 5 minus 3 divided by 2. So that means what? 5 into 2 by 2, that means we have 5. If it is an hexagon, so it will be what? 6 minus 3 by 2. 2 threes are, so that is 3 into 3, 9 diagonals will be having. Okay, so and let me show in a pentagon how the, not only pentagon, any polygon, how the diagonals will be. So this is one. Okay, this is one cross points and this is one, and from here it can go here also, from here to here. These are all diagonals, guys. So this is one. Okay, and now from here to here it can go, then from here to here and here to here, you people can see. So these are the polygons that we basically have here. Okay? So this is what we basically have with regards to diagonals, internal angles, and the sum of internal angles. Now, having this, keeping this in mind, find out. So what is, find the value of x and y. What is this x internal angle? Find the value of x and y. What is this? How many sided figure? 1, 2, 3, 4, 5, 6 sided figure. So guys, tell me fast. I need the answer. 6 sided figure. What's the formula we use? The internal. They're asking only one internal angle. So 60 degree. Dear, is it 60 degree? Check it out. N minus 2 into 180 degree divided by what? N. How many sides we have? 1, 2, 3, 4, 5, 6. So it becomes 6 minus 2 into 180 degree divided by 6. 6 minus 2 is what? 4 into 180 degree by 6. So how many times it goes? So 6 threes are 18. So each internal angle is what? 120 degree. See, look at the stretch only. When you look at the stretch, yes, so it is 120 degree. Okay. So what it is, guys? 120 degree. If simultaneously, what is the sum of the angles here? The sum of the interior angles. Simple. Don't again calculate. If each individual angle is 120, we know that 6 angles are there into 6. Isn't it? So therefore 0, 12, 1 remainder, 6 ones are 6, 7, 20. Very good. Very good, Ansh. So even others also give a try. Give a try for this. How many sides we have? 1, 2, 3, 4, 5, 6, 7. 7 sides. Tell me now. I will not be telling this. Now I want you people to tell this. 7 side. First find the internal angle. 7 minus 2 into 180 degree by 7, which is 5 into 180 by 7. See, you should say, but I am saying what to do. So it is 128.57. Very good, Anush. So very good, very good. Yeah, Sakshi, let us be very accurate here. 128 point, so 57. Let us take it. Okay. So or 128.5 is also good to go with. Okay. So good. So this is what. And what is the sum of the angles, interior angles? The sum of the angles will be? Yes. So which is around 900. So it is 900 we are getting. It is not 899.9. So it is exactly 900 we'll be getting. So 5 into 180 is how much? So 900 here. Okay. So this one, the sum of the internal angles is so 900 degree. Okay. So now, wow, this is also one of the thing we have. What is the value of A plus B plus C plus D? This plus this plus this plus this, they are asking. What are these? They are exterior angles, isn't it? What are those? They are exterior angles. So if they are exterior, very good. So somebody has given me the answer quickly. We know that sum of the exterior angles is 360 degree, but one exterior angle they have given, so that is 40 degree. So what should be the remaining angle sum? The remaining angle sum is 320 degree. Very good. It is what? 320 degree. Okay. Now, if a polygon has 14 diagonals, find the sum of all the interior angles of the polygon. So now they have given the number of diagonals, but you need to find the sum of the interior angles. See how the diagonals are given by The diagonal is given by n into n minus 3 by 2. Okay. We can get the number of sides by doing this. And with the number of sides, you people can calculate the internal angles. So 14 is equals to n into n minus 3 by 2. That is 28 is equals to n into n minus 3. What 28 factors if you take 7 into 4? 7 minus 3 is 4 only. So therefore, n is what? 7. So if n is 7, it is an heptagon, and we know that heptagons we had previously found. So this one, what is that? What is the sum of the angles? So n minus 2 into 180 degree. That is 7 minus 2 into 180 degree. So septagon, sorry. So it is 5 into 180 degree. So which is nothing but, so your 900. Okay? Getting it? Yes. This is how we need to do this. Okay. So now let us study in detail some of the quadries, okay, quadrilaterals, because we have, so among polygons, one of the biggest family, so would be quadrilaterals. Why? Under quadrilaterals, we have many different forms of quadrilaterals here. Okay, so yes. So what is this quadrilateral? Let me explain things. So here basically if you see quadrilateral, usually it is a four-sided figure, isn't it? What we say usually, what is it? A quadrilateral is a four-sided figure. I just randomly write one quadrilateral like this. Usually this can be even considered as a trapezium, but let me consider this as a quadrilateral. So I want you people to know certain parts here. A, B, C, D. Okay, these are parallel sides and these could be non-parallel also, sometimes parallel also. So this is what? This is the diagonal. When I draw a perpendicular to this diagonal, what I am doing? When I draw a perpendicular to the diagonal, so we can draw like that two perpendiculars from the opposite vertices. What are these called as? They are called as offsets. What we call it as? Offsets. In fact, they act as a height of this particular triangle, and here this acts as a this one for particular triangle. Okay, so that's what is offset. Offset is nothing but a perpendicular drawn to the diagonal from the opposite vertex. That is your offset. Okay, so one more quadrilateral you come across. This is the normal quadrilateral, but if I have a quadrilateral which can be circumscribed, if I have a quadrilateral which can be circumscribed, not every quadrilateral can be circumscribed. Okay, but if we have, okay, quadrilateral that can be circumscribed, so that is A, so I can say B, C, D. So this is called as cyclic quadrilateral. What we call them as cyclic quadrilateral. And you people can see here the cyclic quadrilateral. So has one thing. The opposite sides will be supplementary. So what is that? Supplementary means, that means angle A plus angle C should be equal to 180 degree, while angle B plus angle D is also equal to 180 degree. Okay, this is what, so the cyclic quadrilateral we have. Usually otherwise the quadrilaterals have a different behavior. But this cyclic quadrilateral, what you see, the opposite sides are supplementary. Okay, what is that? So we can see that the opposite sides are supplementary here. Okay, so these are little this one features of quadrilateral. But now let us go in particular with our this one. What is that? I can say in particular. Let us try to take up the uh, each quadrilateral here. Let us talk about trapezium. Just 1 second. I'll erase these things. Right. Just give me 1 second, guys. Okay. What is trapezium? Trapezium is that raw quadrilateral where we don't will not find like a same size or something like that. That means why I am using the word raw, in the sense it is like it is a kind of original quadrilateral from which like we have got the square, rectangle, parallelogram, all these things. Okay, usually you can see that the quadrilateral will be like this. Okay, so what is this? Usually the quadrilateral will be given in this way, and you can see here, so A, B, C, D. Okay, this is a quadrilateral. You can see that these are parallel sides. Usually, the basis tends to be the parallel sides, whereas the legs are non-parallel sides. That means at some point they tend to intersect. Okay, what happens at some point they will be tending to intersect here. Okay, so this is what basically we have in our this one. If we have a midpoints here, okay, so if this is the midpoint and this is the midpoint of this, if we join them, so the line joining the midpoints of the non-parallel sides, okay, will act as a parallel. Again, this side will become, what is that? I can say that even where is my this side is parallel to this one also, and this will be parallel to this one as well. Okay, so this is what we basically have when we talk about our this one. Okay, this is the parallel side, and this is again the parallel side. So that means what this will be differentiated, or you can say that so this PQ will be what? Half of the sum of these sides. PQ, or if I take PQ as like this, so what was, because it is in the median, isn't it? So it is in the median. So therefore, if I take, what is the length of the PQ? The side that is parallel to both of them, it will be half of AB plus DC. Okay, what it will be? It is half of AB plus DC. What is the length of PQ? So the PQ is half of AB plus DC we are going to have. Okay. Further, if we take any other parallel line, okay, if we take a parallel line, not exactly the midpoint, somewhere, but if it is in the ratio of m is to n, okay, if it is in the ratio of m is to n, so then what is the length of this side? So say, let us take rs. This is rs. Okay, so this RS is in the ratio of M is to N. So at that time, what we can do, so we can say M times M plus N into longer side plus N times m plus n into shorter side. Okay, so this is the thing we have. Okay, so that means what? This greater portion by this m plus the longer side, and this is n times. Let me draw it here properly. A, B, C, D. If I have a parallel line, so where? So this thing, the differentiation is M, and this in the ratio N. So let me take PQ. So now PQ length is given by what? PQ will be equal to M by M plus N into longer side, which is the longer side. So DC plus. So, and you will be seeing n by, so m plus n into shorter side. Okay. This is how we are going to get this thing. Getting it? So this is what we have. And how do you find the area of a trapezoid or trapezium? We need to have a perpendicular height. Always see a perpendicular length is considered as a height. Okay, so we need to have perpendicular height. So after we get the perpendicular height, we can take that. So area of a trapezium is given by half the time into, so height into sum of, it is sum guys, it is not a plus a into b, it is the sum of the opposite parallel sides, sum of parallel sides. Okay, so this is the thing that we have. Okay, so that is the area of our this one. And so here if you see one more thing, so the perimeter is what? The boundary. Okay, the boundary it is having, the boundary is given by what? The sum of all the sides. That means the sum of the parallels of parallel sides and plus the sum of the non-parallel sides that we have. Okay, so this is what we basically have with regards to trapezium. Now the trapezium gets modified. So when we do little, what is that? Variations by equalizing. So the opposite sides, when we equalize the opposite sides and when we make them parallel. Okay, when we do bit of correction here for the trapezium or the trapezoid, and when we take up, what is that? Opposite sides when we take to be equal, like this. I'm doing little correction. The legs also we made it parallel, and we made the legs length to be same, and the bases also we made it, what is that? Parallel, and bases length. This is what is called as parallelogram. What do we call it as? So parallelogram. So in this, let us know some of the parallel, this one, what is that? Properties of parallelogram. Parallelogram, opposite sides, if I take A, B, C, D. Okay, so what is that we see? A, B, C, D we have. So they are parallel. AB is parallel to CD, AC is parallel to BD. We have opposite sides are parallel, opposite sides are equal. And even if you see opposite angles are equal, that means I can say angle A is equals to angle D, angle B is equals to angle C. Okay, so this is what we have. And also if you see one more thing, in quadrilateral, the sum of the adjacent angles should be equal to 180 degree. That is what is different in the cyclic quadrilateral. See, in cyclic quadrilateral, opposite angles are supplementary. Whereas in quadrilaterals, you pick up any quadrilateral, you will be seeing that adjacent angles. Okay, so they need to be equal to 180 degree. Angle A plus angle B is 180 degree. Angle B plus angle D is 180 degree. Angle D plus angle C is 180 degree. Angle C plus angle A is 180 degree. And how many diagonals we have? We know this is one diagonal and this is another diagonal. And what do you see here? Whether the diagonal length will be same? No, in this case, in parallelogram, so the diagonal length is not same. Okay, so this diagonal will be of different length and this diagonal will be of different length. But one thing that you need to notice here, this at the point of intersection, what happens? Each of the diagonals get bisected. That means so the diagonals are intersecting in such a way that so each of the diagonals get bisected. That means this length is equals to this length, whereas this length is equals to this length. Okay, that means whatever the diagonal we had like this. Okay, so now when I draw a diagonal, one more diagonal, this diagonal gets equally divided. For example, see, this diagonal seems to be little shorter length when compared to this diagonal. That means how can we say that the parallelogram has the two diagonals of same length? No, it won't be having two the diagonals of same length. Why? Because the angles are different. The angle of inclinations are different here. Okay, you can say one is obtuse and one tend to be this one acute here. So because of angles, angle of inclination is different, hence the diagonal length also varies here. Okay, so and also when these things are equal, that means this both are equal, this both are equal. And now when you see the triangles also, now you have what? Four triangles form. In this four triangles, only opposite triangles tend to be same. Okay, so opposite triangles are same, so but not all the four triangles. So keeping all these things in mind, so what is the area? So we can say, we can take the height here. Okay, height is the perpendicular length. So area is given by what? Base into height. What is the area given by? Base into height. Whereas perimeter is what? Sum of the sides. Okay, so therefore say this is A and B and sorry, this is A. So therefore 2B's we have here when I add up and 2A's I have. So therefore the perimeter is the boundary and it is given by 2 times B plus A, or we can say 2 times length plus breadth. Okay, so this is what we basically can get. And now we made little correction for parallelogram. What we did here, we had acute and obtuse. But what we did here, we made each of the angle to become 90 degree. From obtuse, we grabbed some angle and we added here, so that what happens, each of the angle becomes 90 degree. Okay, what is happening here? So you can see here each of the angle become 90 degree. So this becomes our rectangle. Rectangle properties. So all opposite sides are equal. Okay, and each angle is 90 degree here. And not only that, if you see, the diagonals will be equal. Why? See, same side and this one. If you see here, so by Pythagoras theorem, you can get this one. So therefore, the diagonal length will be equal. Even though the diagonal length is equal here, you see here also only opposite triangles are equal. You can see the area of the opposite triangles. That means opposite triangles are congruent here. You get this opposite triangles. Not all the four triangles will be congruent, only opposite triangles will be congruent. And also one more thing I would like to tell you guys here is that, so yes, let me redraw here. The diagonals here also bisect each other. That means this length is equals to this length, this is length is equals to this length. Okay, so that means, so the diagonals here also get bisected. Getting it? So the next thing, and how the diagonal length is given by, as I said here. So if this is A and this is B, the diagonal length using Pythagoras theorem, we can take it as root of A square plus B square. This is the diagonal length we have. Okay, so how do you get root of A square plus B square? Whereas in parallelogram we can't use this thing, but yeah, the extended this one, what is that, this one, obtuse angle, extended Pythagoras theorem for obtuse angle we can use and we can get there. Okay, but here, yes, this is what we basically have here. So this is the diagonal length, okay, of what, our rectangle. Okay, this is the rectangle here. And now, so area is equals to what? Length into width here. Perimeter is 2 times the same thing. And so area can also be equal to what? Half the times diagonal square. Basically, it is half the time into d1 into d2, because d1 and d2 are same. So we can say half the time diagonal square gives us the area here. Getting it? Now, square is what? Further modification of our rectangle only. So in rectangle, we had two opposites, only one pair, two pairs of sides equal. But here we made all the sides equal with 90 degree. Getting it? So everything is 90 degree. Here again, diagonals will be same sized. Okay. So diagonals will be same size. And not only that, we also see that whatever the four triangles are formed, okay, these four triangles tend to be of equal areas. That means the complete squares, this one area, if we divide by 4, we get each triangle's area here. Okay, so that is the thing we have. What is the this one? Square, A square, because both sides are same, so length into breadth, it is nothing but A into A, we get A square. Perimeter is 4A, because the sum of sides, and the diagonal is given by half the time D square. What is the diagonal we have? So half the time D square. Why? Because again here you see that the diagonals are of same length. Okay, so what is this? The diagonals are of same length. Now, one more interesting thing that you have is with regards to rhombus. Okay, what is this rhombus? So you all know that all the sides are equal, isn't it? So even though rhombus, if you see, so rhombus, like, it is again a parallelogram which have the properties of parallelogram. Okay, but here you see that all the sides tend to be equal, but the internal angles are not equal to 90 degree. Like this it will be. Okay, these internal angles won't be equal to 90 degree, and that is the difference between our square and rhombus here. And so if they are not equal to, what is that? So your this one, so this is one diagonal and this is one diagonal. Definitely the diagonal length changes here. If the diagonal length changes, the area is also what? Half into d1 into d2. Okay, so the area is given by half into d1 into D2 is the area of the triangle that we have here. Okay, so now perimeter, sum of all the sides here. So this is what basically we have when it comes to our this one. One more thing I would like to tell here with regards to rhombus. You know, everywhere we know that the diagonal, when they intersect, it is not necessary they form 90 degree. Okay, it is not necessary, they form 90-degree. But in rhombus, if you see, we know it is conform. So it is what? 90-degree. Compulsorily, the diagonals intersect at 90-degree. What happens? So we can use the this one. What is that? The this one. The diagonals they are 90-degree. Okay. Yes. Anush, what is that? We can't use Pythagoras theorem. No, we can't use Pythagoras theorem in parallelogram. How can we use? Because their angles are what? One is obtuse and one is this one. What is that? Your acute angle. Only when we make the this one, what is that? The changes, like for example, here we have a parallelogram. If we try to, what is that, extend this, then we draw the perpendicular height, then 90-degree. If we need to know this also, then we can use. But no, I didn't say, I said we cannot use in parallelogram, but we can use it in rectangle and square. Okay. So maybe while communicating, it would have, we can use it in what? Rectangle and square, but parallelogram, how can we use? So because their angle, so Pythagoras theorem only applies to right angle figures. Okay. So maybe you would have misheard it. Okay. So now, next thing that we have, okay, so based on this, the problems we'll be doing in tomorrow's class. Okay, so I hope you people are clear about this one. What is that? Our theory part, and tomorrow we'll do few problems on the basis of these things. Okay, any doubts you people have? Yeah, you can start asking me. Any doubts? Okay, no doubts. Fine. Practice on them. Okay. So we'll see you tomorrow with more problems. So on the same topic. Okay, guys. Bye.
Thank you, ma'am. Also, if anyone has any doubt related to the Ubergrad website or the links provided, you may ask now. Otherwise, I'll be ending the session. Thank you so much. Also, please try joining by 8:30 p.m. or max by 8:35 so that we can start the session. Thank you.